Have you ever wondered what keeps a colossal ship, weighing hundreds of thousands of tons, from being swept away by the ocean's fury? It's not magic, it's a masterpiece of engineering. The anchor chain. Today, we're diving deep into the world of these unsung heroes of the sea, exploring the science, the manufacturing, and the critical role they play in maritime safety. So, what makes an anchor chain so incredibly strong? The secret lies in a perfect blend of materials and manufacturing. It all starts with high-quality steel alloy. We're talking about steel specifically formulated with elements like manganese and molybdenum. These aren't just random additions. They are crucial for enhancing the steel's hardness, tensile strength, and resistance to the brutal, corrosive saltwater environment. Think of it as a chef creating a perfect recipe, but instead of flavor, the goal is unbreakable strength. Once the special steel alloy is ready, it's forged into massive bars. These bars are then heated to over 1,000 degrees Celsius, becoming bright orange and malleable. This is where the real magic begins. Powerful machines bend these glowing hot bars into the iconic oval link shape, but the link isn't closed yet. The two ends are pressed together in a process called flash butt welding. An immense electrical current is passed through the ends, melting the steel and fusing them into a single, seamless piece. This isn't your average welding job, it creates a bond that is just as strong as the rest of the link. After welding, the entire chain link undergoes a critical heat treatment process. It's heated again, and then rapidly cooled, or quenched, in water or oil. This quenching locks the steel's molecular structure into a super strong formation. Following that, it's tempered reheated to a lower temperature to increase its toughness and reduce brittleness. This two-step process, known as quenching and tempering, is what gives the chain its incredible ability to withstand immense pulling forces without snapping. It's a delicate balance between being incredibly hard and yet flexible enough not to be brittle. Now, let's talk scale. We're not dealing with the chain you'd find at a hardware store. A single link on a chain for a massive oil tanker can weigh over 500 kilograms, that's more than a grand piano. The entire anchor chain, called a cable in naval terms, can be hundreds of meters long and weigh several hundred tons. Each link is meticulously connected to the next, forming a colossal steel serpent resting in the chain locker, ready for deployment. Why is all this strength so necessary? Imagine a supertanker or a massive aircraft carrier in the middle of a storm. We're talking about waves, the size of buildings and winds that can generate millions of tons of force. The anchor and its chain are the only things holding the vessel in place, preventing it from drifting into other ships, running aground, or being dashed against rocks. An anchor chain failure in these conditions isn't just an inconvenience, it's a potential catastrophe, risking lives, multi-billion-dollar assets, and severe environmental damage from oil spills. Think of the anchor chain as the ship's ultimate safety brake. In an emergency, like a complete engine failure, dropping the anchor is the last line of defense. The chain has to absorb the enormous kinetic energy of a moving vessel and bring it to a halt. The forces involved are astronomical. That's why every single link is subjected to rigorous testing. A sample from each batch is put into a massive machine and pulled until it breaks. This destructive test, called a proof load test, ensures that the chain can handle forces far greater than it will ever experience in the real world. Every link of the final chain is also non-destructively tested to ensure there are no hidden cracks or flaws. There is zero room for error. The evolution of anchor chain manufacturing is a story of human ingenuity. Early chains were hand-forged by blacksmiths, painstakingly hammering iron links one by one. They were strong for their time, but couldn't handle the demands of increasingly larger steamships. The Industrial Revolution brought about steam-powered hammers and better steel. But the real breakthrough came with the development of electric welding and advanced steel alloys in the 20th century. Today, the process is a high-tech symphony of robotics, computer-controlled heat treatment, and ultrasonic testing. Modern standards, like those for U3-grade chain steel, demand a level of quality and consistency that was unimaginable a century ago. This continuous innovation is driven by the ever-increasing size of ships. As we build bigger container ships, larger LNG carriers, and more massive offshore platforms, the demand for even stronger, more reliable anchor chains continues to grow. Beyond just holding a ship, these chains have other fascinating roles. On offshore oil rigs, massive mooring chains, often combined with synthetic ropes, keep the platform positioned precisely over a drill site for years on end, battling constant currents and storms. They are the silent, steadfast guardians that make deep-sea exploration possible. The next time you see a picture of a giant ship, take a moment to appreciate the incredible piece of engineering hidden just below the waterline. It's not just a length of metal, it's a testament to our understanding of material science, a critical component of global trade, and a lifeline that protects sailors and our coastlines every single day. From a lump of carefully formulated steel to a chain capable of taming the ocean's power, the journey of an anchor chain is a powerful story of strength and responsibility. Thank you so much for joining me on this deep dive into the world of anchor chains. If you found this as fascinating as I did, Please hit that like button, and be sure to subscribe and turn on notifications so you don't miss our next adventure into the world of amazing engineering. See you in the next one.